Hello students, welcome to the session of Polynomial Part 5. Before starting with this session, I would like to recapitulate what we have done in this chapter. In this chapter, we have done geometrical meaning of zeros of a polynomial, relationship between zeros and coefficients of a polynomial, forming a quadratic polynomial when zeros are given or sum and product of zeros are given. This we have done with a quadratic as well as the cubic polynomial. Division algorithm for a polynomial, finding of remaining zeros or all zeros of the cubic or biquadratic polynomial when one zero is given or two zeros are given. So this all we have done in this chapter. This is the last session of this chapter, polynomials. Here I am going to discuss with you certain questions of this chapter which I feel that it is little difficult for you and more support is required in these two questions. One question is question number 5 of exercise 2.3, where it says give examples of polynomials px, gx, qx and rx which satisfy the division algorithm. These all parts are the parts of the division algorithm. Without these we cannot explain the division algorithm. Okay, now here it says the condition degree of px, that is the degree of a polynomial, is equal to degree of quotient. Under this condition we have to give the example of this which should satisfy. So we are taking that degree of polynomial is equal to degree of quotient. So we assume let we say the degree of both the polynomials are 2. So here if we see the division algorithm, so we say that degree of polynomial is equal to degree of divisor plus degree of quotient. You know it very well if I am having this x to power of 4 is a polynomial. So if divisor is say x, so then quotient will be your x cube, or if divisor is x square, then quotient will be your x square. If divisor is x cube, then quotient will be your x. The sum of its power should be equal to the degree of the given polynomial. So here we have assumed this degree as 2. So when we solve it, so we get degree of divisor. Here we say the degree of divisor is 0. So if degree of divisor is 0, then remainder, this will be a constant term. So degree of remainder is always smaller than degree of divisor. So Rx will be taken as a 0 polynomial. That means here we will be having 0. Okay. So here we are taking a quotient polynomial, that is your x square plus 3, and divisor as the sum constant. So when we are taking this constant term, so when we multiply with the division algorithm, we say that x square plus 3 into 5, we get 5 square x square plus 15. Now we come to the second condition that it says degree qx is equal to degree rx. So here we need to find out the examples of the polynomial where it satisfies this condition. So here we take it as 1. So if we are assuming this one, we know that degree of Rx is lesser than degree of Gx. The degree of Gx will be taken as what? Greater than equal to 2, as we have taken divide this remainder as 1. So here we are assuming x square plus 2 as Gx, Qx as x, and Rx as 2x minus 1. So here we can take any value which should satisfy the degree of it. So here when we put it in the division algorithm, so we obtain this value x cube plus 4x minus 1. Clear? Now we take up the third condition. Third condition says what? Degree Rx is equal to 0. So here degree Rx is equal to 0. So here so Rx is a non-zero constant polynomial if Rx is 0. So here degree Rx will be lesser than the degree of Gx, that means the divisor. So if I am having degree of Rx is 0, the degree of Gx will be greater than equal to 1. So if you are taking this, so we are taking Rx as 3 and degree is taken as 1, the x plus 2. Here I can take Gx as higher than this also. So when we are placing it, the Px will be a Gx into Qx plus 3. So we obtain this value. I hope this is clear. Okay. So if you are having any confusion, kindly pause the video and see it again and again. Your concept will be clear. Okay, now I take up the second question or the next question of exercise 2.4. In exercise 2.4, you see the question is given if the polynomial x to power of 4 minus 6x cube plus 16x square minus 25x plus 10 is divided by another polynomial x square minus 2x plus k, the remainder comes out to be x plus a. Then you have to find out the value of k and a. So here we will be dividing this polynomial by this polynomial and we will find out the remainder. Here says that remainder is x plus a. So now when we divide it, you see the step, then here in divisor we are having another variable other than x and we have to find out the value of k. So how we will do this division? So you see in the first step what we are multiplying with x square. When we are doing with x square, the rest of the things are same. Here we are getting kx square. So kx square, when we are subtracting this from 16x square, we will write in this manner. We will have this 16 minus k bracket x square. We will not leave it open. We will not write it 16x square and then minus, because in coming step it will create a big confusion. So we are taking x square common, writing in this way. In the next step, you see we are getting this minus. To obtain minus 4x cube, we will multiply this divisor by minus 4x. So we get it minus 4x cube and here 8x square minus 4kx. Now when we do the subtraction, we need to open this bracket. We will do it this way, that is 16x square minus k x square minus 8x square. So we will be left over with what? 8x square minus kx square, and then we again take it as 8 minus k and x square common. So here we are getting 8 minus k x square. Okay. Now this will be again x will be taken common outside, and we will be having 4k minus 25x and 10 of here is being copied down. Clear? Now the last term, you see here we have taken 8 minus k. To eliminate this 8 minus k, so we will multiply this divisor by 8 minus k. So we get 8 minus k x square. This will get eliminated, and when we are multiplying with the second, so we are getting 16 minus 2k inside, x outside, and minus sign outside. This minus sign is kept outside and remaining only the positive value is being multiplied. Clear? And here I get it this. So when we do the normal subtraction, we get it 2x minus 9x plus 10 minus 8k plus 8k square. So here we obtained this remainder. Now you see that in this form we had but the remainder which was given is what? X plus a. Now we compare it. So here the coefficient of x is this 2k minus n, and here is x. So here the coefficient is 1. So we are comparing 2k minus 9 with 1 is equal to 1. So when we solve it, to get the value as 5. Okay, now by comparing with this constant term, so with constant term, so we are having 10 minus 8k plus k x square, k square. So we are comparing this, and we will be comparing, then we will be getting the value of a as 5 by putting the value of k here. Clear? Now by this we will be getting this value of k as 5 and a is equal to minus 5. Clear? Okay, now I take up one question which has already been asked in the board. Number 1, if alpha and beta are zeros of polynomial fx is equal to x square minus 5x plus k, such that alpha minus beta is equal to 1, find the value of k. Now here we are using this alpha and beta, these are the given zeros, are the zeros of this polynomial fx is equal to x square minus 5x plus k. The sum of zeros will be what? Sum of zeros will be alpha plus beta is equal to, we know it that this is your minus b upon a. So here b is what? Minus 5. So minus 5 upon 1 we are getting as 5. Now here alpha beta, that is the product of 0, that is your k upon 1, that is equal to k. And here already given alpha minus beta is equal to 1. So we are using this alpha minus beta is equal to 1, and when we use this alpha plus beta and alpha minus beta, so we get the value of alpha as 3. So when we are getting this value of alpha as 3, so we place it in the sum of the zeros, the equation number 1. So here we find the beta as 2. So when I am getting the beta as 2, so this k is what? K is your product of zeros. Here you have getting here alpha beta is equal to k, the product of zeros. So we have already the value of zeros. The 3 and 2 when we multiply, so we get it as 6. So this is one question. And another question which was asked in the board, this is another kind. Here it says alpha and beta are zeros of the polynomial 2x square minus 5x plus 7. Then find a quadratic polynomial whose zeros are 3 times alpha plus 4 times beta and 4 times alpha plus 3 times beta. Now in this case, if you see that we need to find out another polynomial whose zeros are 3 times alpha plus 4 times beta and 4 times alpha plus 3 times beta. So here our zeros are what? Alpha and beta. So we will find the sum of zeros by comparing with the coefficients of the x square and x. So here we will get it what? 5 upon 2, and the product of zeros, that is your 7 upon 2. We need to find what? Quadratic polynomial. So another quadratic polynomial whose zeros are these. So we consider this as alpha dash and beta dash. So here the sum of zeros, when we are finding out the quadratic polynomial, we require two things, the sum of zeros and the product of zeros. So here we are taking alpha dash and beta dash, the sum of zeros. So here we get it as 35 upon 2. This is given what? 7 times alpha plus beta. So alpha plus beta was the value. Here 5 upon 2. So we are taking, that is become 35 upon 2. Yeah. The product of zeros. The product of zeros is the alpha into beta dash. So when we multiply these value of zeros, we get this kind of equation. And here we are getting 12 times alpha square plus beta square plus 25 alpha beta. So this can be written in this form, as we know in the algebraic form a plus b whole square is equal to a square plus b square plus 2ab. So I have written here that is a plus b whole square minus 2ab. Clear? In this form we have written in terms of alpha and beta. So we get 12 times alpha plus beta whole square minus 24 alpha beta plus 25. So here alpha beta, again we will take the value of alpha plus beta, that is sum of the zeros of the given polynomial. So here we get it as 5 upon 2 whole square plus 7 upon 2 with solving it. So we get it as here the product of zeros as 157 upon 2. So we have obtained this product of zeros and sum of zeros for the which we have to find out the quadratic polynomial. Okay, so as per this generalized one, k times x square minus alpha dash beta dash x plus alpha beta dash. So here we are placing the value, that is your 35 upon 2 and 157 upon 2. When we place it and solve it, by after taking out LCM, we will get k upon 2, 2x square minus 35x plus 157. So this we are getting. So here when we are writing it down the quadratic polynomial, so for certain value of k, this we assume here k is equal to 2. So we get the final polynomial as 2x square minus 35x plus 157. Clear? Now I will give you more questions which have already been asked in the boards. Here are these questions. This I am reading around. If one zero of quadratic polynomial, if one zero of the quadratic polynomial 2x square minus 3x plus p is 3, find its other zero, also find the value of p. Clear? So in this one, the 1 0 is given and you have to find out the value of p. So here this you can use the factor theorem as you have used in class 9. Okay, so with the help of that you can do it. Here it is given alpha beta are zeros of the polynomial p x square minus k plus 6 times x plus 2 times 2k minus 1. Find the value of k if alpha plus beta is equal to 1 by 2 alpha beta. Now here in this question, k, this relationship is given ki sum of the zeros is equal to half the times of product of zeros. By using this relationship, you can find out this. So here the sum of zeros will be what? That will be a k plus 6 upon 1. And product of zeros will be what? 2k minus 1 into 2. So this will be a product of zeros. So 1 by 2, and when you place it, so you can find it out. Yeah. Third one, if alpha and beta are zeros of quadratic polynomial kx square plus 4x plus 4 such that alpha square plus beta square is equal to 24, find the value of k. The same way, so you will be using sum of zeros and product of zeros and the algebraic identity, that is your alpha plus beta whole square is equal to alpha square plus beta square plus twice alpha beta. So that your identity you will be using it and then you can find it out. Now that fourth question says ki what polynomial of least degree must be subtracted from the polynomial so that they say this polynomial, from this polynomial you are subtracting it, when you are dividing this becomes a factor. So it is similarly as you have done in the previous class also, with what it should be, what number should be subtracted so that it is divisible by, completely divisible by a given number. So there we were using a whole numbers, here we are using the polynomial. So you will divide it, whatever the remainder you get it, you will subtract it from here, so you will get it. Okay. Now in the fifth question it says if the polynomial 3x4 power 4 minus 4x cube minus 16x square plus 15x plus 14 is divided by another polynomial x square minus 4, The remainder comes out to be px plus q. Find the value of p and q. The way I have shown you in the previous last question, the same way it will be done. Clear?